Theta is this angle here. Now, can we say this angle is an angle of inclination? Based on the definition that we know for an angle of inclination. It's not again. Because an angle of inclination is an angle between an x-axis and a line again. So if that's the case, then it means we are going to check which this angle is between which two lines. That's what we are going to concentrate on. Let's check which this angle is between which two lines. The angle theta is between which two lines. If we look at this, it's between the y-axis again. And then it's also between not only the y-axis, but it's also between the what then? The line AB. Can you see this again? So this line that we're talking about is created by, and then it's an obtuse angle which is created by the red and the green color. Again. Now, what is the next thing about we identify? We'll simply write which this thing here is created by AB. So I'll write which here I have AB. And then I'll also write which is also created by the y-axis. So I'll simply say it's y here. So it's created by the AB and the y-axis. What is the next thing that I'm going to do from here? I am going to make sure which I create a triangle with the lines that form the angle and the x-axis. So what I need to have here is this. I get the x-axis here, it's black in color. Can you see this? So I need to have black, green, and red. They need to intersect with each other. So when they intersect with each other, this is what I'm expecting to have. So I'm expecting to have the green again. And then I'm expecting to have the red. And then I'm expecting to have the black. So I have something that looks like this. So this one here is a straight line. Let's not forget. This one is going to be a straight line. And then there's where you find your theta then. Now, what is the next thing that we're going to do? We're going to calculate the gradient of these two lines. Now, the y-axis here, the gradient of this thing here, it's undefined. We don't have a gradient of this thing here. It's undefined. Because remember, what is a gradient? A gradient is a slope. Okay? Now, if your gradient is a slope here, the y-axis doesn't have a gradient. But now AB does have a gradient. So I'm going to calculate the gradient of line AB. I'll say the m of AB is going to be given by y2 minus y1 all over x2 minus x1. Okay? Now let's go and check here. Are there any 2 points that I can use to get the gradient of AB here? Do we have any 2 points on the green line? Are there any 2 points that you can use here? There are no 2 points that you can use, okay? But now you can then say, but now this line is parallel to this one, okay? Yes. If this line is parallel to this one, in this which I can say this is going to be equal to m of DC. Now I know what are the coordinates of D and the coordinates of what? C. Now if we do it alphabetical, this one is going to be x1, this one is going to be y1. This one here is going to be x2, this one is going to be y2. And then if we go and then do the substitution, it says which you are going to get minus 5, minus open bracket, minus 3. All over minus 2, minus open bracket, 2. And then you type this in your calculator. If you type this in your calculator, what did you get? You get 1 all over 2. So it means which is the m of AB is going to be equaling to 1 all over 2, because we know that AB is parallel to DC. That was this fine again. Now we can then come and get the angle of inclination here, which is the angle alpha. It's an angle between the green line and the black line, which is the x-axis again. So we'll come and say we have the tan of alpha, which is going to be given by m of AB. And then it says alpha is going to be given by the tan arc of 1 all over 2. And then it says, if you say 10 arc of 1 all over 2, in your calculator, it's 36,26. So we get 26. It's 26,57 degrees. So we'll come and write it here and say, okay, now this one here is 26,57. Okay? Now we still want this, we still want this gradient here. What is going to be the angle here? We still want to know what is going to be the angle here. Now, if you look at these two lines here, against the x-axis and the y-axis, okay? What kind of an angle are you going to have between the x-axis and the y-axis? It's a 90 degree, yeah. And x-axis and the y-axis, they're always going to be actually perpendicular to each other, making this angle to be equal to actually 90 degrees. And then we come and say, if this one here is 90, we want to get theta. How would we get theta? Can you see theta again? Theta is an angle outside again. Now, what can you say about an angle outside?
It's equivalent to area of this.
So it's going to be equal to this angle plus this angle again. Then it makes, which will say that our theta is going to be equal to 26,57 plus 90. What is going to be our reasoning? It's exterior angle of a triangle. Then it means which what is going to be our theta? Our theta is going to be 26 plus 90. But it's 116,57 degrees. And then we are done with this one then.